Let's solve this question. 2 points on a velocity time graph have coordinates 5 seconds, 10 meters per second, 20 seconds, 20 meters per second. Calculate the mean acceleration between the 2 points. Remember, this is a velocity time graph. Velocity is here, and here is time, is it not? When you have a coordinate, 5 seconds, 10 meters per second, coordinate is s1, y1, x2, y2. I hope you know that. So the x1 is the horizontal axis, the y1 is the vertical axis. So the first x1, this is x1, y1. What is the first x1 on the horizontal axis? 5 seconds. What is the first y1? 10 meters per second. Because this side is velocity, here is time. Come over here. This is x2, y2. Here is x1, y1. So what is the first x2? 20 seconds. The x2 is 20 seconds. Y2 will be what? 20 meters per second. This is in seconds. This is in meter per second. So the graph of velocity time graph is what we call the acceleration, is it not? So now, what is the coordinate, the slope of this graph, which is the acceleration? If I go to this side, I'm going to determine the slope from here. So the slope is going to be what? Change in what? Change in velocity over change in time, is it not? V2 minus V1 over T2 minus T1, is it not? So it's going to be what? It's going to be, what's V2? 20 minus 10. 20 minus 10 over what? Over 20 minus 5. 20 minus 10 is what? 10 over 20 minus 5 is 15. 10 divided by 15 is what? Is equal to 0.67 meter per second square. So that is the answer. So this is a velocity time graph again, right? In the velocity time graph of a car which starts from rest, this car starts from rest because you can see it started from 0 and is accelerated uniformly at the rate of 3 meters per second square for 5 seconds. This is a uniform acceleration till this place. It attains a velocity which is maintained at this velocity. This velocity here is 4 meters per second. It maintains this velocity for 1 minute. From here to here is 1 minute. The car is then brought to rest by a uniform retardation after another 3 seconds. After another 3 seconds, this is uniform retardation. Calculate the total distance. From this graph, you will see that it maintained a velocity which is maintained for 1 minute. From here to here is not 1 minute, it's 20 seconds. So this should be 20 seconds. This time is in seconds for 20 seconds. The car is then brought to rest by a uniform retardation after another, from 20 to 25, after another 5 seconds. Calculate the total distance. Total distance in a velocity time graph is area under the graph. All right, look at the graph. Looking at this graph, what is the shape of the graph? This is shape of trapezium. So area of the trapezium is the total distance covered. Looking at this graph as well, this graph is a triangle, a rectangle, and another triangle. So either you say the shape of the area of the trapezium or area of the triangle plus area of the rectangle plus area of the triangle will give you the same thing. That is the total distance, area under the graph. Okay, let's work as area of trapezium. This is a trapezium. What is the area of trapezium again? Area of trapezium is what? Half A plus B times height, is it not? So half, what is A? A is the first base. From here to here is 25 plus here to here is 10 to 20, which is 10. What is the height from here to here, which is 4? So what is the answer now? Half 25 plus 10 is what? Is what? Is 35. times 4. 35 times 4 is what? 140 divided by 2, which is what? 70. So 70 meter is the total distance. 70 meter is the total distance. Or I can still say that area under this graph is the area of this triangle plus area of the rectangle plus area of this triangle. This is a triangle, this is a rectangle, this is a triangle. It will still give me the same. What's the area of this triangle? Half base times height, is it not? Area of the first one, area of the triangle plus area of a rectangle plus area of another triangle, which is this one. What's the area of this triangle? Half base times height, is it not? Times length times breadth, plus length times breadth plus half base again times height. Half, what's the base of this triangle? From here to here is 10. What's the height? Here to here is 4. Plus length from here to here is what? 10 to 20 is 10. What's the breadth from here to here, which is 4? Plus half again. What is the base? 20 to 25 is 5. And what is the height? 4. Still going to give me the same. 10 times 4 is 40 divided by 2, 20 plus 10 times 4 is 40 plus 5 times 4 is 20. 20 divided by 2 is 10. 20 plus 40, 60 plus 10, 70 meter. So whichever way you get the correct answer. A car starts from rest and accelerates uniformly for 5 seconds until it attains a velocity of 30 meters per second. It then travels with a uniform velocity for 15 seconds before decelerating uniformly to rest in 10 seconds. Look up. Sketch a graph of the motion. So this is the velocity time graph. Using the graph above, calculate the acceleration during the first 5 seconds of the motion. Deceleration during the last 10 seconds. Deceleration, not decelerating, deceleration during the last 10 seconds. Total distance covered during the whole journey. So it's a velocity time graph. We have to draw the graph first, is it not? Here is velocity and here is time. If a car starts from rest, I told you that it's going to start from 0. Here is 0, is it not? It starts from rest and accelerate uniformly. This is a uniform acceleration, which I've told you, is it not? This is a uniform acceleration. For how many seconds? Bring it down. Look at what we are doing. How many seconds? 5 seconds. At what velocity did it attain? It attained the velocity of 30 meters per second. Here is velocity in meter per second. Look at it. A car starts from rest, accelerate uniformly for 5 seconds. Time is 5 seconds, and the velocity is what? 30 meters per second. It then travels with uniform velocity. It does not change the velocity. It travels with this velocity. It then travels with uniform velocity for 15 seconds. The next 15 seconds should come down. Here is 5. If it's next 15 seconds, here will be what? Here will be 20 seconds, is it not? So here becomes 20 seconds. Then what happened again? Before decelerating uniformly to rest, after traveling for these 15 seconds, he decides to come to rest. This is this uniform deceleration. So decelerate uniformly to rest in 10 seconds. Next 10 seconds from 20 seconds, we make it what? 30 seconds. That's the total time. 30 seconds. Sketch the graph of the motion. This is the graph of the motion. Then, from the graph, using the graph above, calculate the acceleration during the first 5 seconds. That's the uniform acceleration from here to here. Is it not? Acceleration during the first 5 seconds. Before it starts moving, what is the initial velocity? 0. What is the final velocity? 30. What is the time? Time is what? 5 seconds. A is what we are asked to calculate, is it not? So V is equal to U plus AT, is it not? V is 30 equal to 0 plus, what is A? We don't know. What is time? Time is 5, is it not? So 30 is equal to 5A. Divide by 5, divide by 5. So what is the acceleration? Acceleration is 6 meters per second square. So the acceleration from here to here is 6 meters per second square, is it not? Then what's the next question? This is I question, I. This is I question. What's the next question? Deceleration during the last 10 seconds of the motion. The last 10 seconds of the motion before it comes to rest. When a body comes to rest, final velocity is 0, is it not? So V is equal to 0. Then what is the velocity? The velocity is 30 meters per second. From here to here, what is the time? Time is 20 to 30, that is 10, last 10 seconds of the motion. Calculate the acceleration, that is the deceleration. So we still have V equal to U plus AT. Why is V 0? Because it's coming to rest. When a body comes to rest, V is equal to 0. Then this becomes the initial velocity. So V is 0. 30 plus A times time. So 30 plus 10A. 10A come over here. Minus 10A equal to 30. Divide by 10. Divide by 10. A is equal to what? So minus 10 minus 3 meter per second square. The minus indicates that the body is decelerating. Is a retardation, as I told you earlier. Then the last one is total distance covered during the whole journey. The total distance is area under the graph, area of this trapezium or area of this triangle plus area of this rectangle plus area of this triangle. That is very simple to calculate. If I say area of the trapezium, total distance is area of the trapezium. What is the area of the trapezium? Half A plus B times height, is it not? Half, what is the A? A is the first base from here to here, which is 30, plus from here to here, 5 to 20 is 15, is it not? What is the height? Height is from here to here, or from here to here, which is 30 times 30. 2 go into 30 is 15. So we have 30 plus 15 is what? Is 45. 45 times 15 is what? Is 675. 675 meter is the total distance traveled. Or you can still say area of the triangle plus area of the trapezium. Sorry, area of the rectangle plus area of the triangle. What is the area of this triangle? Half base times height, is it not? What is the base? 5. Half 5 times, what is the height? 30, is it not? Plus length from here to here, 5 to 20 is 15 times what? 15 times the breadth, which is 30, plus half again. Base 20 to 30 is 10. What is the height again? 30. So what will happen here? If 2 cancel here is 15. 2 cancel this is 10, is 5. So this is equal to 5 times 15 is what? 5 times 15 is 40, 75. 5 times 15 is 75. 15 times 30 is 450 plus 5 times 30, 150. 150 plus 150 plus 450 plus 150 is 600, is it not? Plus 75, that is 675 meter. So it's the same thing. So the answer is 675 meter.